Students, welcome to the third session of our fourth module in CFF. So this module deals with Fanno flow. Fanno flow is that flow in which driving potential is friction, wall friction. Students, today we are going to learn about Fanno relations. Fanno relations for a perfect gas. Okay. So what are the various temperature, pressure and density relations in case of a perfect gas? Okay, so students, consider a flow passage. Okay, so this must be a constant area duct. So I'm taking a section 1 here, another section 2. Okay, so let this be adiabatic process insulated. So there is no heat transfer across the duct. So let the pressure at section 1 is P1, temperature T1, density ρ1, enthalpy H1, stagnation pressure P01, moving with the velocity V1 and Mach number M1. Okay, so let the temperature and other values be P2, T2, ρ2, H2, P02, moving with the velocity V2 and Mach number M2. Okay, so students, the stream properties at the reference section. So here we know that in the isentropic cases and also in normal shock and all, the properties were expressed in terms of ratio properties like T1 by T2 or P1 by P0 like that, right? The students, you know that expression for the variation fluid properties along the length of the duct for a Fanno flow process can be expressed in terms of some algebraic form, right? So which are obtained from one-dimensional conservation equations. So in a Fanno flow, we can take the critical state. Critical state means the state where Mach number is unity or the state where entropy becomes maximum as the reference state. Okay, so hence the properties at critical state are employed for what? Non-dimensionalizing the equations. So the equations for the property ratios can be written in terms of flow Mach number and specific heat of the fluid, right? So what is mean by non-dimensionalizing? Means if you have to get an expression for T1, better you non-dimensionalize it by making it a ratio of temperature. So if you make it non-dimensionalize it based on critical section means T1 by T star. So T star is the value at critical section. Critical section is a section where Mach number equal to 1, right? Or entropy S max, the state where entropy becomes maximum in a Fanno flow. So T1 by T star is a non-dimensionalized value because it is a ratio. So there is no dimension for this term. Alright. So we use critical state properties for non-dimensionalizing the various parameters. Okay. So in order to non-dimensionalize it, the reference section is critical section, can be obtained by providing an imaginary extension for the duct. Okay, so I am extending this duct such that somewhere here there is a section called star section, critical section, where where pressure is P star, temperature is T star, density is rho star, enthalpy is H star. Okay, and one more P0 star, stagnation P0 star, but velocity V star and Mach number is Mach equal to 1. That is the peculiarity of this particular section. Mach number, value of Mach number will be 1. Okay, so students, we have learned while studying the governing equation since the process is adiabatic, stagnation enthalpy remains constant because there is no elevation effect. So H0 will be equal to H01 equal to H02, and Cp T0 will be equal to Cp T01, okay, equal to Cp T02. Since we are dealing with the perfect gas, Cp will be common, Cp will be constant. Cp will be constant. So Cp can be cancelled, right? So you can get T0 will be equal to T01 equal to T02. So the stagnation temperature value remains constant at any section. Constant at any section. So here students, you can write that here also T0, here also T0, here also T0. Stagnation temperature value remains constant at any section through the duct if the flow is what flow is Fanno. So I'm taking this particular length as L, means here to here, from section 1 to 2 the length of the duct will be L. Okay, so students, now our aim is to find the temperature ratio. So but we have T0, value of T0 in terms of static temperature can be written as T1 plus gamma minus 1 by 2 max square. So this is the expression for stagnation enthalpy, stagnation temperature. So if T01 can be written as T1, okay, 1 plus gamma minus 1 by 2 max square. So T02 can be written as T2 1 plus gamma minus 1 by, okay, so this is not T1, okay, into M square. Oh, this is M1 square, this is M2 square, right? So students, but T01 is equal to T02. T01 is equal to T02 means T1 1 plus gamma minus 1 by 2 Mach 1 square should be equal to T2 1 plus gamma minus 1 by 2 M2 square, right? So T2 by T1 can be written as 1 plus gamma minus 1 by 2 Mach 1 square by 1 plus gamma minus 1 by 2 Mach 2 square, right? So this is the ratio of temperature, the static pressure ratio of temperature at two different sections. So students, I have told you that it is better to non-dimensionalize it with a reference state. So reference state is critical state. Critical state is taken as the reference state. Okay. So you can also use stagnation state as a reference state, but it won't do much simplification. It won't be easy to simplify such equations. So better you use a critical section as a reference state. So if T1 equal to T star, T1 can be taken as T star if M1 is equal to what 1, right? So this equation can be written as T by T star if 1 plus gamma minus 1 by 2 max square by, instead of 1 plus gamma minus 1 by 2 into 1 square, right? So this is the format. This equation can be changed to this form, this particular form, right? Where corresponding to star you have to put a Mach number as 1. So if you simplify this equation, you will get T by T star as what 1 plus, sorry, 1 plus gamma minus 1 by 2 max square by 2 plus gamma minus 1 by whole 2, right? So 2 plus gamma minus 1 is 1 plus gamma, 1 plus gamma, it means 1 plus gamma minus 1 by 2 max square by 1 plus gamma by 2, right? So this is the equation for This is the equation for T by T star, right? T by T star can be written in this form. Okay, there is a small mistake. Actually, here you can see that if T2 is in the numerator, M2 should be in the denominator. If T1 is in the denominator, M1 should be in the numerator. So corresponding to T star, you should put mac equal to 1 here. Okay. So that's a mistake. I'm sorry for the mistake. So T by T star should be in the form 1 plus gamma minus 1 by 2 into 1 square by 1 plus gamma minus 1 by 2 into max square, right? So corresponding to T, max should come here. Corresponding to T star, max should be 1 here. So if you simplify it, you will get gamma plus 1 by 2 by 1 plus gamma minus 1 by 2 max square. So this is the equation for T by T star. Okay, this is the ratio of T by T star. Now we have to move, we can calculate pressure ratio. Pressure ratio can be written as along two sections. P can be written as rho RT, right? So P, so according to continuity equation, rho 1 V density into velocity. So this is volume flow rate. Volume flow rate is constant. So rho 1 V1 should be equal to rho 2 V2, right? So rho 1 by rho 1 can be written in terms of rho can be written as P by RT, right? So P by RT V1 is equal to P1 by RT1 V1 is equal to P2 by RT2 V2, right? Students, instead of V1 and V2, we can write it as P1 by RT1 into M1 into A1. A1 is root gamma RT1, okay? Equal to P2 by RT2 into M2 root gamma RT2, right? So P2, this R and R cancels, gamma R cancels. What remains is P2 by P1 can be written as M1 by M2 into root this T2 comes here in below, right? So sorry, T2. So actually what remains is, okay, this T1 and root T1 cancels, means root T1 remains here, 1 root T2 remains here. So you can have this root T2 there here in the numerator and root T1 in the denominator. So this can be written as M1 by M2 into T2 by T1 all raised to half. So P2 by P1 can be written in this manner, right? So are you getting the point? Okay. So P2 by P1. So P2 by P1 can be written as M1 by M1 by M2, okay? M1 by M2 into T2 by T1 all raised to half. But students, you have already found out a relationship for T2 by T1, right? So T2 by T1 can be written in this manner. So substituting this, so write this equation as 1, okay? Substitute equation 1 in 2, 1 in 2. So you will get P2 by P1 as M1 by M2 into 1 plus gamma minus 1 by 2 M1 square, okay, by 1 plus gamma minus 1 by 2 M2 square, right? So whole divided by root of the whole term, because this half is here. So now if P1 can, so from this you have to get P by P star. P by P star can be obtained using by substituting for P1 M1 can be substituted with m1 is equal to 1. Okay, substitute m1 equal to 1. Substitute m1 equal to 1. You will get 1 by m into gamma plus 1 by 2. Numerator will become like that. Denominator remains same, all raised to half. So this is the equation for P by P star. Okay. All this T by T star and P by P star will be available in the value for T by T star and P by P star for particular Mach number. So these equations are now a function of Mach, upstream Mach, right? Upstream Mach, the corresponding Mach number and gamma only, right? So now you obtain T by T star as a function 1 of gamma and Mach. Similarly, P by P star again another function of gamma and Mach. So if you know the value of gamma and the corresponding Mach number, you can easily get T by T star and P by P star. So these values will be tabulated in your Fanno flow chart in your data table. Okay. So now we have to obtain the equation for rho 2 by rho 1. So rho 2 by rho 1 is nothing but P2 by RT2 by P1 by RT1, right? So that is P2 by P1 into RT1 by RT2. So R and R cancel, which remains is what remains P2 by P1 and T1 by T2. So students, P2 by P1, relationship for P2 by P1 is already known to you from the previous equation. So P2 by P1 is here. So substitute this equation. So rho 2 by rho 1 is nothing but P2 by P1. P2 by P1 can be written as M1 by M2 into 1 plus gamma minus 1 by 2 m1 square by 1 plus, it should be, let me check, it should be m1 square, okay, m1 square by gamma minus 1 by 2 m2 square, right, whole raised to half into, now you look at T1 by T2. So T1 by T2 is, okay, T2 by T1 is here. T2 by T1 is there. So T2 by T1, the inverse of T2 by T1, we'll get it as T1 by T2. So that will be 1 plus gamma minus 1 by 2 m2 square by 1 plus gamma minus 1 by 2 m1 square. So students, here you can see this is m2 term, this is m1, here also m2. So this is m1, this is m1 term. So try to cancel it. Okay. Or you can get rho 2 by rho 1 as m1 by m2 remains, and what else? 1 plus gamma minus 1 by 2 Mach 2 square raised to half remains, and 1 plus gamma minus 1 by 2 Mach 1 square raised to half. So this is or you can write it as in a bracket. So the half is common for whole term inside the bracket. So okay, so rho by rho star can be written as 1 by m, because corresponding to 1 you should put star. So m1 will become 1 and m2 will become m. So it will be 1 plus gamma minus 1 by 2 Mach square by, this will become gamma plus 1 by 2, gamma plus 1 by 2 all raised to half. Okay, so this equation for rho by rho star, rho by density ratio. Now if you want the equation for v1 velocity 2 by velocity 1. How to find? You know rho 1 v1 is equal to rho 2 v2. Therefore v2 by v1 will be equal to rho 1 by rho 2, right? So v2 by v1 can be written as rho 1 by rho 2, but rho 2 by rho 1 is already obtained here. Rho 2 by rho 1. So inverse of this will give you rho 1 by rho 2. So rho 1 by rho 2 can be written as m2 by n1 into 1 into 1 plus gamma minus 1 by 2 mach 1 square. Here it should be 1 by 1 plus gamma minus 1 by 2 mach 2 square whole raised to half. So this is the equation for v2 by v1. And now you can get the equation for v by v star. V by v star as actually it should be m by 1. M by 1 is m itself. Gamma plus 1 by 2 by 1 plus gamma minus 1 by 2 m square all raised to half. So this is the equation for v by v star. V by v star is exactly the inverse of rho by rho star. Sorry, rho star, it will be rho star by rho. It will be rho star by rho. Now we can find stagnation pressure ratio. Stagnation pressure ratio. Okay. So what is stagnation pressure? How to find stagnation pressure? Stagnation pressure P0 by P will be equal to 1 plus gamma minus 1 by 2 max square whole raised to gamma by gamma minus 1, right? Right? So P0 will be equal to, so if you take that P here, P0 will be equal to static pressure P into 1 plus gamma minus 1 by 2 max square all raised to gamma by gamma minus 1, right? So students, P02 by P01 can be written as P2 by P1 into 1 plus gamma minus 1 by 2 mach 2 square whole raised to gamma by gamma minus 1 by 1 plus gamma minus 1 by 2 mach 1 square whole raised to gamma by gamma minus 1, right? So students, P2 by P1 you know, so substitute that P20 by P01 will be equal to P2 by P1 is m1 by m2 into 1 plus gamma minus 1 by 2 mach 2 square by 1 plus gamma minus 1 by 2 mach 1 square whole raised to half, right? Okay, so m1 opposite minus half. So it should be like here it should be 1, should be 2 here, 1 here, 2 here. Okay, so that is P2 by P1. So this is P2 by 1. What remains? This term remains. So this term is 1 plus gamma minus 1 by 2 mach 2 square whole raised to 1 plus gamma minus 1 by 2 mach 1 square whole raised to gamma by gamma minus 1. So students, this is m2 here, this is m2 here. Okay, the power of this term is half, power of this term is gamma by gamma minus 1. So what should be done? So P02 by P01 can be written as m1 by m2 into 1 plus gamma minus 1 by 2 into mach 1 square whole raised to 1 plus gamma minus 1 by 2 m2. So here it should be half minus gamma by gamma minus 1. Here also half minus gamma by gamma minus 1. So half minus gamma by gamma minus 1 can be written as gamma minus 1 minus gamma all raised to 2 gamma minus 1. So this and this cancel. Actually it remains minus 1 by 2 gamma minus 2, right? Or 1 by or it can be written as 1 by 2 minus 2 gamma, right? Oh, sorry, actually it is product, so this is product, so you should add this. It's a mistake. So half plus gamma by gamma minus 1 can be written as gamma minus 1 plus gamma by 2 gamma minus 1, right? So it will be 2 gamma minus 1 by 2 gamma minus 1. Still again a mistake is there. Can you find out? Can you note down the mistake? So try. I have made a mistake. Actually, here this is m1, this is m2 here. Actually, this should be my. This should be this term divided by this term, or you should take the inverse of this, gamma minus 1 by gamma. Okay. എന്നുവെച്ചാൽ ഇത് ഈ ടേമിൽ m1ഉം ഈ ടേമിൽ m2 ആണ്. അപ്പോൾ ഇത് ഡയറക്റ്റ് പ്രൊഡക്റ്റ് അല്ല, ഇത് ഇൻവേഴ്സ് എടുത്തിട്ട് പ്രൊഡക്റ്റ് കാണുന്നിരിക്കുന്നല്ലേ. സോ ഐ വിൽ ഡിലീറ്റ് ദിസ് സ്ലൈഡ്. ഓക്കെ, സോ ഐ വിൽ റൈറ്റ് ഇറ്റ് വൺസ് മോർ. സോ p2 by p02, okay, p02 by p01 can be written as m1 by m2 into 1 plus gamma minus 1 by 2 m1 square by 1 plus gamma minus 1 by 2 m2 square whole raised to half into better okay, so I am taking the inverse. Inverse means I will add a negative in the power. So 1 plus gamma minus 1 by 2 mac 1 square, mac 1 square by 1 plus gamma minus 1 by 2 mac 2 square, and it should be like minus gamma by gamma minus 1, right? So it will be m1 plus m1 by m2 into 1 plus gamma minus 1 by 2 mac 1 square by 1 plus gamma minus 1 by 2 mac 2 square all raised to half minus gamma by gamma minus 1. So our first approach was the correct one. So half minus gamma by gamma minus 1 can be written as gamma minus 1 so how to write half minus gamma by gamma minus 1? Gamma minus 1 minus 2 gamma by 2 gamma minus 1, right? So it will be like minus 2 gamma minus 1 by 2 gamma minus 1, or it will be minus of gamma plus 1 by 2 gamma minus 1. Okay, so instead of here you can write it as minus of gamma plus 1 by 2 gamma minus 1, right? So this is the equation for p02 by p01. So if you need p0 by p0 star, you just put m2 as m and m1 as 1. So that's the. So we will get an equation like p0 by p0 star as 1 by m. into 2 gamma plus 1 in bracket 1 plus gamma minus 1 by 2 max square all raised to gamma plus 1 by 2 gamma minus 1. Okay. So this will be the equation. So just try to do on yourself. So now impulse function, impulse function f as p into 1 plus gamma m square. Do you remember this equation? So f1 by f2, sorry, f2 by f1 can be written as p2 by p1 into 1 plus gamma m2 square by 1 plus gamma m1 square, right? So f2 by f1 can be written as p2 by p1 is nothing but m1 by m2 into 1 plus gamma minus 1 by 2 m1 square by 1 plus gamma minus 1 by 2 m2 square all raised to half. Okay, so this much is p2 by p1, rest is 1 plus gamma m2 square by 1 plus gamma m1 square. Okay, you simplify or you put, then you will get f by f star as, by putting m2 as m and m1 as 1, you will get final answer like this: 1 plus gamma m square by m into 1 plus gamma into gamma plus 1 by 2 1 plus gamma minus 1 by 2 m square all raised to half. This will be the equation if you will obtain if you put m1 as 1 and m2 as m. Okay, so that's it. Now students, the final is change in entropy. Change in entropy. So students, you know the HS diagram. HS diagram for Molière diagram for Fanno flow. So there is a maximum entropy point here. So there is a constant stagnation enthalpy value for any. So if I am taking 1 here and 2 here, this will be S1, this will be S2, corresponding stagnation state is here. So therefore S01 will also be this one, this will be S02. So S2 minus S1 will always be equal to S02 minus S01, right? Because this stagnation entropy and static entropy will be same. Now equation for S2 minus S1 is nothing but Cp log T2 by T1 minus R log P2 by P1, right? So students, S2 minus S1 can be written as S02 minus S01 itself, right? So these two terms are equal. Therefore, Cp log T02 by T01 is minus R log P02 by P01. So S2 minus S1 can be written as in this term itself. Okay. So T0 by T01 is same because you know that H0 equal to H01 equal to H02. Similarly, T0 equal to T01 equal to T02. So T02 by T01 is 1, log 1 is 0. So this term is cancelled. So what remains is S2 minus S1 can be written as R log minus R log P02 by P01 or R log P01 by P02, right? So you already have P01 by P02. Okay, this P02 by P01 is already available with you. Just substitute this equation here. So S2 minus S1 will become R log Mach 2 by Mach 1 into 1 plus gamma minus 1 by 2 mac 1 square by 1 plus gamma minus 1 by 2 mac 2 square whole raised to gamma plus 1 by 2 gamma minus 1. Right? So this is the equation for S2 minus S1. So if you need to find S2 minus, sorry, S star minus S, star minus S means, so this will be corresponding to, this will be S star, okay, maximum entropy. S star will be maximum value of entropy, can be found using the equation you put, if you, S will become S star, S1 will become S if S2 will become S star if M2 is equal to 1 and S1 will become S if M1 is equal to M. So on substitution you will get the equation 1 by M into 2 by gamma plus 1 into 1 plus gamma minus 1 by 2 M square. Okay, whole raised to gamma plus 1 by 2 gamma minus 1. That's the equation. That's the equation for S star minus S. Okay. So students, one important factor here that we have to study is that friction coefficient. So basically this is a friction flow, or Fanno flow is nothing but friction flow. So friction coefficient, so you have studied in your fluid mechanics class and all, friction coefficient F can be, so fanning define friction coefficient as fanning friction coefficient, that is average shear stress by dynamic pressure half rho v square, right? Half rho v square. So students, tau by half rho v square is the fanning friction coefficient. But tau can be written as tau, shear stress can be written as friction force by, or tangential force by what? Area of the wall. Right? If you know the area of the wall, you can write as area of the wall can be written as perimeter into distance. Perimeter into distance. This is a surface area. Surface area can be written if your perimeter, the vector perimeter into length dx, through which flow takes place. Okay. So if you know the perimeter, you can calculate the area. So you know the area. So Ft can be written as friction coefficient into half rho v square into what? Ft can be written as tau into area, right? Tau into area. Tau is nothing but friction into half rho v square into area, right? So half rho v square into area. Area is Pw dx, right? Pw dx. So it can be written as rho v square by 2 into F Pw dx. So students, now you have studied in your fluid mechanics like fan, a hydraulic d is nothing but hydraulic coefficient, sorry, not hydraulic characteristic diameter, or hydraulic diameter, d hydraulic diameter. If you know hydraulic diameter, the hydraulic diameter d is defined as 4 times surface area by wetted perimeter. So wetted perimeter can be written as hydraulic diameter into 4 times area, right? 4 times area. So substituting this here over here. So instead of perimeter, half rho v square into f into what? Dia into 4 times area into dx. Okay. So substituted like this. So the equation will become F tangential force due to wall friction. Tangential force Ft is tangential force due to wall friction. Tangential force due to wall friction. So Ft can be written as rho v square by 2 into 4f dx. Sorry, here it should be like d equal to, actually d equal to 4a means pw equal to 4a by d, 4a by d, not like this, 4a by d. So if we substitute here, it should be like 4a divided by d. Sorry for the mistake. So 4f dx by d into a. Okay. So this is the equation for tangential force. So tangential force can be written as what? Half rho v square into area into 4f dx by d. So here f is Fanning's friction coefficient. Fanning Fanning is friction coefficient. Okay. Similarly, Darcy's friction coefficient is there. Darcy's friction coefficient is f dash is equal to 4 times Fanning coefficient. 4 times Fanning coefficient. So instead of this, you can substitute f dash there. F dash. So ft can be also written as half rho v square into f dash dx by d into area. Okay. So actually this f and f dash are not a mean value. If you want to find the mean value of f dash can be found out using the equation 1 by L integral from 0 to L f dash dx. If you integrate this, you will get the value of mean f dash. Okay. So these are the equations related to friction coefficient. So if you are doing problem, you will get a deeper idea about this concept. So if you have to find out a pressure drop due to friction, pressure drop in a duct, pressure drop in duct due to friction, just delta P in a length L can be found out using the tangential force due to wall friction by area. So that will be half rho v square 4f dx by d into area whole divided by area. So area and area cancels. So what remains? So instead of dx, you should put L, because here it's L, length is L. Okay. So you put it as L, length is L, not dx. 4f L by d. So area and area cancel. What remains is delta PL is equal to half rho v square into friction coefficient 4f into L by d. So this is the equation for pressure loss. So that's it for this session. Thank you.